So thank you for being here. My name is PACKEXPO. I'm the president of Chicago Electric, and we appreciate the chance to get a few minutes of your time to talk about 3D vision and robotics. I'm not sure if everybody's aware, but this is the challenge. This is the fun part. So PMMI a couple months ago said, pitch us an idea to put 5 things in a bag. And they gave us a bag and they gave us 5 things, and that's all the guidance we got. 6 things. The lovely Mrs. Caskin reminded me as always. So it's an interesting challenge. So if you haven't done so far, take a look at the 5 companies here who are executing this task. Everybody has a different approach, and that's what I was really curious to see. So our approach is leveraging 3D vision technology. Our system is different in that we're doing it all with one robot, and we're doing it with no secondary material handling. So we'll talk a little more about that, but that's one of the key advantages of what we're doing is we're picking directly from the bins without any other handling. Our partners in technology are Motorman Yaskawa and Solomon. Both are also exhibiting here, so I'd encourage you to go take a look at their booth. Chicago Electric is an integrator. We're in the business of merging those technologies into a complete solution. What I often say to people is if you look at a bucket of Cheerios, it's easy for any of you to say, that's the next one I should pick. You just know how to do that. If you're a robot, it's not intuitive. The robot's staring over that bin. How do we know which is the next one to pick? And that's the essence of 3D vision. And that's one of the big breakthroughs in robotics in the last 5 years. The technology gets better, the technology gets smaller, the technology gets less expensive. And we'll show you some examples of that. As I mentioned, our technology partner is Solomon. Happy to say Chicago Electric was the first integrator in the U.S. about a year ago for Solomon. Very innovative. There are a series of products that they make related to 3D vision. We focus on 2, primarily the AccuPick software, which is what we're showcasing here. And then also we'll show a video of the Soul Motion, which is vision-guided robotics for 3D. When I talk to my robot buddies at ABB and Motorman, they always refer to 3D bin picking as the holy grail, the end point. Where are we going to find the technology to give that robot the chance to just reach in and grab the next piece? So it's been going on for a while, but I think we're really at that point in the technology where it's, as I said, much more affordable and versatile. So the way it works, the way ours works, is we're going to use artificial intelligence, and I'll show you a couple of examples of how it's structured. And we're going to think real hard about those objects and remember their form, and then use that to train the robot to make them fit. We can work with a wide variety of objects. We can work with trained objects or untrained objects. We can work with a CAD file, but we don't have to. So one of the advantages of Solomon is we don't have to ask you for a CAD file to figure out your product. We can train the system to do it. There's 2 camera technologies. The more accurate high resolution is what's shown here. It's a structured light technology. And you'll see it in the videos. You get this little flash of light. We're taking 24 images of the bin and then combining those images to take the best choice of the 3D image. Over here we have a less sophisticated and much smaller form factor system that uses a time-of-flight technology. But the software is all the same. So we have a big one that's high resolution and a small one for more coarse pick and go. All of them use the artificial intelligence or deep learning technology. Another advantage of Solomon, it'll work with 20 different brands of robots. So it will take complete control of the robot motion and can do that for all the major brands. So how does this work? What did we have to do? Well, we wanted to try doing it with what they call unknown objects. But we have a little trouble with the Scooby Snacks. So the Scooby Snacks, when we lay them down, it's hard to tell which one is a bag or if 4 of them look like a bag. So we had to move to trained objects. So what that means, it takes a little time, but it's the difference of it working or not, is we lay the Scooby Snacks out, or the Eclipse gum, and we take a series of photos. We take maybe 15 or 20 photos of how they might appear to the robot. And then we go in and we mark, we circle, in a PC technology, we circle or define a Scooby Snack. And so now we can train the robot to know what a Scooby Snack looks like, and away we go. So it's interesting, I always say this, but it really doesn't. It just sort of crawls off, and we sit there and process for an hour. So it does take some time if we're doing trained objects. But after that, and it really works, it says, okay, I'm ready, show me some Scooby Snacks. And it works. So if you walk over there, you'll see it. We have these screens running. You can see the overall image in 3D, and then you can see the target image being acquired, and that's what we go and grab. There are several other suppliers of 3D technology. Basically, the way it works is the same. Siemens is right over here. They're using the same camera, different technology, but the way it gets done is much the same. This is another example. If you come to the booth, you'll see this exactly. So we lay out the product, we capture a series of images, we train on those images to define what we want to grab, let the computer think about it for a while, and away we go. As I mentioned before, the advantage of Solomon is they can work with 20 different robot brands. They're all programmed, ready to go. It's not trivial. You're going to need a nice integrator to help you with it, but it's very powerful software. So the Realsense camera, this is the latest technology. So this is made by Intel. This is a $200 camera. You can buy it on Amazon. It's what you hook it up to that makes the difference. So by hooking it into the Solomon software, we're able to achieve the 3D bin pick. A couple things different with us. As I mentioned, we don't have any material handling. Our friendly co-exhibitors have conveyors or ways to bring product in. We set the bucket on the floor, and we can go 90 minutes before we have to reload. So there's no primary handling of the part. That's the key of bin picking. I got a bin full of stuff and I just keep picking. I don't have to orient it. I don't have to convey it in. I don't have any of that expense. So we have the biggest, fastest robot and the least expensive solution on the floor. So the Realsense camera, the biggest innovation of it, it's a very small form factor. Siemens has one, we have one. So I can put it on the end of the arm of the robot. So now I can look at multiple bins. So we've added a different software layer with a standard Allen Bradley PLC so that we can continually have control of the robot. And we only go to Solomon when we want to make that last pick. So if you watch our system run, we come to each bin, we hold in a pre-pick position, we calculate the next pick, and that's what we do. But the rest of the program and the motion of the robot is done through standard either Motorman or Allen Bradley technology. As I mentioned, it's a slightly different technology. It's an infrared camera, so it gives us a low-cost solution, and the key factor is we can mount it right to the robot. So what I have left here are a few examples, some videos. This is unknown objects. This is really where we want to be able to get to quickly, where we do not have to go through that training. This exists if you have fairly uniform and clearly defined. So if you have boxes of toothpaste, it goes all day long. If you have Scooby Snacks that are layered on top of each other, it's a little bit of a challenge. But this is a typical example where we don't have to do any programming. We have unknown objects, but what have been pre-programmed is common shapes, tubes, cartons, squares, that are easily defined. The edges are very clear. When we have those types of products, we can pick without any pre-programming. Some other examples. This is with the high-res camera. You'll see, as we go through, you'll see that flash of light. That's 24 images being taken simultaneously. And that's how we pull together the pick image. We have a customer just like this. It's little bags of nuts and bolts, lots of little bags of nuts and bolts, but they're not consistent. They're smooshed up or whatever. But the artificial intelligence has been trained to be able to distinguish it enough that even a box of squishy parts in plastic bags, we can identify the next ones to pick. So e-commerce, logistics, packaging, it starts opening up some opportunities. Little things and big things. So little things, and then the really little things. I'll let the video play. Some operator error here. There we go. What we want to simply show here is that we can pick up very small objects. So what this starts taking us into is alternatives to bin feeders. So instead of cycling things through a bin feeder to get them to present, we can just throw them on the table and start picking them one at a time. So with the high resolution camera, we're able to get down and very accurately identify the next one to pick. Decal. Lots of robots as you walk through the show are doing palletization. They're real good at picking up uniform boxes and putting them in an oriented stack. Well, what if the stuff shows up at the warehouse and you've got all sorts of boxes? It's reality. It's not a nice clean pallet. That's where 3D vision comes in. Because we can look at that array and we can make choices about which one we're going to pick next. So random decal is an important opportunity for 3D. If we watch the whole thing, it'll nicely stack all of those, but take my word for it. This is an intriguing one. So one of the things in the synopsis of the presentation was fixtureless processing. So if I want to glue something, the typical way to do it is I bolt it down and I tell the robot to follow a pattern. But wouldn't it be nice if I could just set it down and I don't have to fixture that device? That's what we're able to do here with that component. So we're gluing a car hood here. And we know how it should work. You take a picture of the hood. So now we have the relationship of the path to the part. But what if some salesman grabs that part and moves it? Can we still work? The answer is yes. So I can rotate the part, I can shift the part, but because I have a 3D map and I know where to start, if that starting point moves, I can still get there. So now we have a fixtureless process. So it's a subtle point, but an important one, because if I have to build, if I'm running all sorts of different sizes, and I got to build a fixture to hold them, if I can just set it down and use the 3D camera to tell me where to start very accurately every time, now I can step away from those fixtures. Like a commercial tire. So next door, we have a piece of literature on the standard where we're picking from a normal application, you're going to pick apart and put it into a machining process. Today what we're showing is if we can put the camera on the end of the robot, we can pick multiple bins. We're not stuck with just the same bin every time. And that's an innovation that we've brought in conjunction with Solomon. And then we said, okay, if we could pick 12 bins, maybe we could pick 300. And this is where we're trying to go in a silo concept. So I used wine because everybody understands the bottle of wine. So in this concept, I have 300 cases of wine arranged in a silo. And it's an e-commerce solution where you want to order a case of wine, but you want everyone to be different because variety is the spice of life. Right? So that's not going to be easy for the typical distributor to do. They want to sell you a case because they don't want to walk some guy out there and pull bottles. So that's the concept here. I can pull from 300 different cases, one at a time, plus I have payload capacity to reload the entire case into the silo. So this is based off a standard GP 180-120, 120 kilograms, over 200 pounds of payload capacity. 300 locations because I got 150 drawers, and I'm going to put 2 cases in each drawer. And I'm going to use the robot to go up, pull the drawer open, get in that pre-pick position, identify the next bottle of wine that's available, grab that bottle and stick it in the case that's waiting down below. So that's an example of a 3D camera and robot e-commerce fulfillment, but arranged instead of aisles in a silo concept. But this could be anything. At 200 pounds per, I could have 150 locations of a 200 pound something that I can pull automatically. So in summary, this is where Chicago Electric is trying to go, and taking off-the-shelf technology and put it together. Some future things, the decal. My personal favorite, the GoBot. Let's put a big robot on a big AGV and go pull tires out of a semi with 3D vision. And ultrasonic cutting. So we showed that gluing application. We now have technology for ultrasonic cutting. So on the end of the end of arm tool is a blade, but the blade's vibrating at 18,000 hertz. So ultrasonic cutting for trimming, plastic, or automotive headliners, rugs, that's where it's being used. So, and that would require the 3D vision for that fixture. So with that, it's a big thank you for hanging around and listening to it all. Come and visit us, the big blue robot right across the aisle, and I'll be happy to try to answer any questions. Thank you.